So the next problem, and you just want to read through all this. Finally, it says construct a 95% confidence interval estimate of the mean wake time. So again, you're picking out that they want you to do a confidence interval, and it has to do with a mean. That's the important part of this. That way you know which thing to use in StatCrunch. You also have to know what the confidence level is supposed to be. Mine, it says 95%. They gave me the information from the sample. We had 15 subjects, and this one is also kind of confusing because it gives you all this information, but what they want is the confidence interval for the population with the treatment. So that means where they're giving you the information after the treatment. So where it says after treatment, then use those numbers after that to put into your StatCrunch. It's 15 subjects, that means my N would be 15. So that means my sample size is going to be 15, and they had a mean wake time of 97.5 minutes. So that's my sample mean. And then standard deviation of 20.9 minutes. Okay, and then for me, it's asking for a 95% confidence interval, so I'm going to leave this at 0.95. So then in my results, I'm looking for the lower limit and the upper limit again. So once you get that, then it's going to ask you to kind of compare to the one before the treatment. For me, if my confidence interval went from 85.9 to 109.1, before treatment, the mean was 104. That's in between my two limits that I got for my confidence interval after the treatment, which means that it's saying that it didn't really change that much. If it had been where the 104 wasn't in between those two, then we could say it had changed a lot. But since it is in between those two, then it probably didn't really change at all. What we'd say is the confidence interval includes the 104 because it's between those two limits. And that means the means before and after the treatment could be the same. And that means the treatment probably doesn't have a significant effect. This is why I was saying it's really important to read the question and figure out what they're asking for. This one is not asking you to find a confidence interval, it's asking for the required sample size. So what this is asking you for is to use that minimum sample size formula. This is a different one than what you did for your M&M project because this has to do with means, not proportions. So this is a different formula. So I'm just looking at the week 10 notes, and there's a whole thing in here about finding the minimum sample size. This one for means, it's a little bit harder because you have to find a way to estimate the standard deviation. So it's that formula where it says n equals, you still have to find a z value just like you did for the other sample size formula. You have to estimate the standard deviation, that's the little sigma with the star. And then for the E, that's your maximum margin of error. This time you're not going to be changing things to a decimal. You just take whatever the number is. Because we're not talking about proportions anymore, we're talking about means, and those can be anything. I mean, if we're talking about the value of a house, it could be, 150,000 or something. So we just take whatever the number is. Where it says within, that's telling you your maximum margin of error. So where it says within 7, you're going to use for the E. And it says assume that sigma equals 25, so that's your estimated standard deviation. That's going to be the sigma star in the formula. Then it tells you 95% confidence. So you need to figure out the Z that goes with 95%. When you're studying for your test next week, I'm going to tell you those critical values for Z, they're all the same as long as your confidence level is the same. So for 95%, the Z Alpha over 2 is like 1.96. It's always going to be that. For 99%, for this it's 2.576, or you can use 2.58. And for 90%, it's going to be 1.65. So those ones, when you go to take your test next week, you can just have these written down so you don't have to refigure them every time. Anyway, so this one on mine, it was asking for 95%. So I know I'm going to use 1.96 for the Z part of that formula. So I'm going to do all of this, do the multiplication and the division, and then square the answer. So for mine, I would have the 1.96 for the Z. So it gave me 25 for the sigma. And it said within 7 IQ points, so this is going to be a 7. Again, I'm not changing that to a decimal. I'm just leaving it with whatever number they gave me. So I'm just going to do that on my calculator. Okay, and mine came out to be exactly 49. You should probably end up with a lot smaller sample sizes for these than you did when you were doing the proportion ones. Those ones tend to be pretty big. These ones tend to be fairly small. So on this one, if it came out to be 96.04, you're going to round it up to 97. So even if this is less than 0.5, you're still going to round it up. Always with the sample size ones, you round up. If you really want to do it on your calculator, there's a way to do that, and it's not that hard once you get it set up, but it's easier to do it in StatCrunch. So in StatCrunch, you just need to have a blank data editor open, and you want to do stat calculators and do chi-square. So this one, it's asking me to do the 2 critical values for 98% confidence level. So I'm going to try putting in 0.98 over here. All right, so just in case anybody missed that, all I did was I went to StatCrunch and I did the chi-squared calculator. So stat calculators and chi-square. I used the between, and I had to put in the degrees of freedom. That's 1 less than the n. So here where my n was 20, I put in 19 for my degrees of freedom. And then I just take the confidence level and put that as a decimal and put it into the right box. So the box on the right, and then do compute. And that gave me my 2 answers. The smaller one went in for the first answer, and the bigger one was the second answer. Okay, so this one, and you can, when it says this to view the table of chi-square critical values, you can just ignore that because we can use StatCrunch for this. So this one, it's kind of breaking it down into different parts. So first, it's asking you for the degrees of freedom. That's still the n minus 1. So for mine, it's going to be 22 since my n was 23. Then it's going to ask me for my 2 critical values. So I'm going to go back to my chi-square calculator over here. I'm going to put in 22 for my degrees of freedom. And then they want, for mine, they want a 95% confidence interval, so I'm going to put 0.95 over here. Okay. So that gave me my 2 values. Hopefully the one with the little L should be the one on the left, so it should be the smaller one. And then the one on the right is the bigger one. Okay, and then last of all, they want the actual confidence interval. So for this, you can use StatCrunch also. I mean, you can use the formula for this if you want. It's a little bit complicated either way because the formulas are actually for the variance. The standard deviation is the square root of the variance. So for this, you have to do stat and variance stats. And we're going to do one sample with summary because we don't have the data, we just have some information. So it's going to ask you for the sample variance. That's going to be the square of the standard deviation. So in mine, they gave me S equals 65.3. I have to square that to get the number to put in for the sample variance. So 65.3 squared. So yeah, mine came out to be 4,000 and something. The N is the sample size. So that's going to be 23 for mine. And then I'm looking for a confidence interval, and it's asking on mine for 95%. So I just need to square my standard deviation and then put in my sample size, the N, do the confidence interval. And then what it's giving me for these is the lower limit and upper limit for the variance. So for each of these, I have to take the square root. So to put my answers in my stat lab, for the lower one, I'm going to take the square root of what it says for the L limit on here. So mine, I'm going to do the square root of 2,550.521. And that's going to be the answer that I'm going to put in here. So mine is going to be 50.5. And then for the other one, the bigger one, I'm going to take the square root of my upper limit. So that's going to be 92.4. The way you can tell that these are kind of reasonable answers and semi-close to right is that if you look at what they gave you for your S in the problem, so in mine, my S was 65.3. That should be somewhere between these two numbers that I got. So yeah, 65.3 is between 50.5 and 92.4. It just has to be somewhere in between those two. If it's not, then you missed something somewhere. Okay, then the next one. This one, again, you can ignore that where it says about the table. So first, you're just doing a 95% confidence interval. And this is one where you have to pay attention to what they're asking. It's a confidence interval for the population standard deviation. So that means in StatCrunch, you'd be using that variance stats again. And you have to square everything or take the square roots. And the first one is for bank A. And this one, it gives you the data so you can do the thing where you open it in StatCrunch. You want to do stat, variance stats, and then you're going to do one sample. And this time you've got the data, so you're doing with data. So if they give you this, just the sample size and the standard deviation, then it's with summary. But if they give you the list of numbers, then it's with data. So first they're asking for the one for bank A. And this is a confidence interval, and mine, they wanted 95% confidence. When you get to this point, though, you still have to take the square root of the lower limit and the upper limit to get the answers to put in to my stat lab. So in these ones on mine, they came out to be pretty small numbers. When you do the square root, they're actually going to get a little bit bigger. So it should make a little bit more sense when you do that part. But remember, for this one, you're talking about the standard deviation, so it's likely to be quite a bit smaller than what your data values are. Because we're looking at the actual data, then it makes sense that our standard deviation is pretty small compared to those. Okay, and then after that, they're asking for the confidence interval for bank B, so you can just go and do the same thing. You can even go back and edit this and put bank B instead of bank A. And then remember to take the square root of both of your answers to get the numbers to put in. Then after that, they're going to have you compare the two confidence intervals. And again, what they're looking for is whether they overlap or not. On mine, it came out that they didn't overlap at all. The one, the highest value is 0.94. And for the other one, the lower limit is 1.27. So there's a big gap in between those two. If you drew them on a number line, they'd be two completely separate intervals with no overlap. So what that means is that there's a significant difference between the two. Okay, read through all this stuff and get down to the end. It says construct a confidence interval estimate of the standard deviation. So that means we're going to use that variance stats one again. And this time they just gave us the sample information. They didn't give us the actual data. So that means in StatCrunch we would do variance stats, one sample with summary. So to get the sample variance, we're going to have to take the standard deviation they gave us and square it. So mine is 41.9. So I'm going to square that, and that's going to give me my sample variance to put in here. And then for the sample size, it's how many subjects there were. So in mine it says there were 14 subjects. So that would be my sample size. And then I want a confidence interval, and it's going to tell you the confidence level. Mine is 98%. So I'm going to check confidence interval, put in my confidence level, and then do compute. And then for my answers, I'm going to have to take the square roots of both of those numbers. So yeah, this is really a trick question. I hate to say this. If we're talking about a standard deviation can't be negative anyway. So if one of these numbers was negative and the other one was positive, when they're saying about the interval contains 0 minutes, that doesn't even make any sense. Okay, if that happened, it wouldn't make any difference. So all those ones where it talks about 0 minutes, those are out. And then if we did this right, the standard deviation they gave us for the sample should be between the two limits that we came up with. But it doesn't say that in all of these. It's talking about the numbers for the mean. That's not even what we were looking at. We were looking at the standard deviation, not at the mean. So any of those where they're using whatever number they gave you for the mean, you can throw all those out also.
So it's the one no.
Yes, it's the one no. This doesn't tell us anything about whether the treatment's effective or not.